everyone, welcome to today's lesson. Let me introduce myself. My name is Ayudya Astiti with my student ID is 241301111 from class 4A of Mathematics Education. In this video, we're going to discuss some very important topics about set, relation, and function. And also don't worry, we'll go through everything in a simple and easy to understand way. So make sure you watch until the end. Okay. Now we move to the first topic, which is about set. So what exactly is a set? So basically a set is a collection of certain objects that can be clearly identified. Look around your environment. You can easily find group or collection. For example, a group of two-legged animals such as chicken, dogs, and birds. So this group of two-legged animal is considered a set because whenever an animal is described as having two legs, it definitely belongs to this group. Now, consider this example. It's a collection of beautiful paintings. Is this a set? The answer is no, because beautiful painting is subjective. For instance, I might think that a painting on this screen is beautiful, but others may not share the same opinion. In other words, a collection of beautiful paintings cannot be clearly defined. Alright, now we understand what a set is. Let's move on to how we can represent a set. With the first method, which is the descriptive method. In this method, a set can be represented by describing the characteristic shared by its member. For example, set C equals prime numbers between 10 and 14, which are 11, 13, 17, 19, 23, 29, 31, and also 37. Next, we have the enumeration method. In this method, the element of a set can be written by listing all of them. If there are too many elements, we can use three dots, these symbols, to mean, and so on. For example, set E equals A, I, U, E, O. Set F equals 2, 3, 5, 7, 11, 17, 19. Set G equals 2, 4, 6, 8, and so on until 20. And lastly, set H equals all integers from negative infinity to positive infinity. In set F, all elements are listed. Meanwhile, in set G, not all elements are written. Only the first few like 2, 4, 6, and 8. And also the last element is 20. If arranged from 2, 4, 6, and so on up to 20, the total number of elements is 10. Set F and G are called finite set, while set H is called an infinite set. Okay, lastly, we have the set builder notation. In this method, a set expressed using symbol and notation, just like describing set with words. In mathematics, symbol and notation are very important to avoid misunderstanding. So, you guys have to pay attention to the following rules. The first rule is the name of a set is written using capital letters such A, B, C, and so on. Second, the element of a set written inside curly bracket, like this. Third, each element is separated by a comma. Fourth, if there are too many elements, use three dots. Fifth, the symbol is read as is an element of and show that something belongs to a set. Example, 11 is an element of A. Next, or lastly, this symbol is read as is not an element of and show that something does not belong to a set. Example, 15 is not an element of A. Alright, let's continue. In set builder notation, we use symbol to describe the condition for membership in a set. Example, set A is the set of all x such that x is a prime number between 10 and 14. So this symbol is read as such that or with the condition that. Next, let's move on to the important terms in set. In set, We will often encounter several important terms such as the universal set, empty set, and others. Let's take a look at each of them. The first, we have cardinality. Cardinality is the number of distinct elements in a set. In other words, cardinality shows how many elements are contained in a set. To represent the number of elements in a set, we use notation and it is usually written as this symbol, which is read as the number of elements in set A. Example, set A equals letter formatting the word cermat. To form the word cermat, we need the letter C-E-R-M-A-T. In other words, A equals C-E-R-M-A-T. Since there are no repeat letters, the total number of elements is 6. So the cardinality set is 6. Next is the universal set. Simply put, a universal set is a set that contains all the elements or objects being discussed. So all the other sets we are talking about are part of the universal set. The universal set usually denoted by the letter S. The element in a universal set vary depending on the context. For example, if we are using even and odd numbers with between 1 and 10, then the universal set is a number from 1 to 10. Like this. 1, 2, 3, and so on up to 10. From this universal set, we can form other set even number. Set A equals 2, 4, 6, 8, 10. And second, its odd number is which is set B equal 1, 3, 5, 7, and 9. Now you can see that set A and set B are part of the universal set. That's why it is called the universal set, because it includes all the elements being discussed. Lastly, we have empty set. An empty set is a set that has no element at all. In other words, there is nothing inside the set. The empty set can be written as this symbol or this symbol too. You can read as a P. For example, you're asked to mention the name of day that start with the letter Z. Think about it. Are there any, right? No, right? Since there are none, the set is empty, and it can be written as E equal this symbol. E equals the empty set. Now is example application. In a grade 8 class, some students join extracurricular activities. The students who join the basketball club are Andi, Budhi, and also Citra. We want to group these students into a set. So the answer is the set of students who join basketball can be written as set A equals Andi, Budhi, and Citra. Okay, after understanding set, the next step is learning how elements from one set can be related to elements in another set. This is called a relation. First, what is a relation? A relation from set A to set B is a connection between each element in a set A and element in a set B. In other words, a relation from set A to set B can be defined as a subset of A cross B. There are also three important terms you need to know. Like the first one is set A is called the domain, set B is called the codomain, and lastly, the element in set B are actually paired with element in A are called the range. Next, let's move on to ways to represent relation. A relation between two sets can be represented in three ways. Let's go through them one by one. The first one is a row diagram. It shows the relationship using arrows that connect elements from set A to element in set B. Second is ordered pairs. Besides arrow diagrams, a relation can also be represented using ordered pairs. This is done by pairing elements from set A with elements from set B in others. We can take the same example from the arrow diagram and write it as ordered pairs. Third is Cartesian diagram. In this method, we represent the relation using point on a coordinate plane. Each ordered pair is written as a point or dot, showing the relationship between elements of set A and set B. Alright, now let's move on to an example to see how these three methods are applied. Here are the results of the data collected about the favorite subject of 5th grade 8 students, presented in the following table. Okay, the first method is arrow diagram. For the first method, we use an arrow diagram. Let's set A equals Aisyah, Burhan, Cynthia, Durrahman, and Aisman, and set B equal mathematics, science, social studies, English, arts, skill, and sports. The relation is favorite subject, which connect element in set A to element in set B, like this. Aisyah connect to math and science. Burhan connect to science, social studies, and arts, and also the others. Next, we represent the relation using ordered pairs. Here is the relation from set A to set B written as ordered pairs. Aisyah in mathematics, Aisyah in science, Burhan in science, Burhan in social studies, Burhan in art, Cynthia in skill, Cynthia in sports, Durrahman in English, Durrahman in arts, Aiman in mathematics, Aiman in science, and also last one is Aiman in skill. Like this. And the third method is Cartesian diagram. In this method, we represent the relation using a coordinate diagram. The elements of set A are placed on the horizontal axis, this, while the elements of set B are placed on the vertical axis, this. Each point or dot represents a pair of elements from set A and set B that are related. Now is the example application. In a grade 8 class, some students have their favorite subject. Andi likes mathematics, Budhi likes science, and Chitra likes English. The relationship between student and their favorite subject can be expressed as a relation. Now, let's write this relation in the form of ordered pairs. The answer is the relation between student and their favorite subject is R equals Ani in mathematics, Budhi in science, and last one, Chitra in English. Alright guys, now we've learned about relation. Let's move on to more specific concept, which is function. You can think of a function as a special type of relation. So understanding relation will really help you understand function more easily. So let's continue to the concept of function. Function or a function is a relation that connects each element in set A, called the domain, to exactly one element in set B, called codomain, and the result of this mapping from domain to the codomain is called range of the function. Now let's move on to the ways to represent function. Just like relation, function can also be represented in three ways. The first one is a row diagram, second ordered pairs, and third is Cartesian diagram. Now, let's look at one example using an arrow diagram. Suppose set A equal 1, 2, 3 and set B equal 1, 2, 3, 4. A function from A to B can be illustrated as this picture. So, from this picture, we can conclude that the domain is set A equal 1, 2, 3 and the codomain is set B equal 1, 2, 3, 4. And the range of the function is 2, 3, and 4. Up to this point, we can say that a function is a special type of relation. Every function is definitely relation, but not every relation is a function. That's why there are specific conditions that must be met for a relation to be considered a function. So what are those conditions? To answer that, we can move on to the next topic, which is condition for a relation to be a function. Now, to answer that, we can move to the next topic, which is condition for a relation to be a function. Now, let's take a look at this picture here. The diagram on the left does not satisfy the condition of a function because there is one element in the domain that is paired with more than one element. For example, A sub 3 is paired with B sub 1 and B sub 4. So the left diagram is not a function. Next, let's take a look at the middle diagram. This one is kind of the opposite of the first case. Here, there are an element that is not loyal. In the middle diagram, there is one element that has not paired at all, basically single or unmatched. So this diagram also not a function. Now, take a look at the right diagram. The diagram on the right is a function because each element in the domain is paired with exactly one element in the codomain. So there are no elements with multiple pairs. Next, let's move on to the types of function. The first one is injective function. An injective function is a function where each element in the codomain is paired with at most one element from the domain to the codomain. In this type of function, some element in the codomain may have no pair. In this diagram, example of an injective function because each element in the codomain, which is set B, is paired with only one element from the domain, which is set A. Even though there is one element in the codomain that has no pair, which is 4, it is still considered an injective function. Next is surjective function. A surjective function is a function where every element in the codomain must have at least one pair. In this case, elements in the codomain are allowed to be paired with more than one element from the domain. This diagram is a surjective function because every element in the codomain, which is set B, has at least one pair, so no one is left unmatched. Even though some elements have more than one pair, such C in 3 and D in 3, it is still a surjective function. Next is bijective function. A bijective function is a function where every element in the codomain has exactly one corresponding element in the domain and no element is left unpaired. If we look at the diagram, all elements in the codomain, which is set B, are paired 1 to 1 with element in the domain. In a bijective function, the number of elements in the domain must equal to the number of elements in the codomain, so that they can be paired perfectly one by one. And lastly is example application. In a class, each student has a unique attendance number. For example, Andy has number 1, Budhi has number 2, and Citra has number 3. This relationship shows that each student is paired with exactly one attendance number. So is this relationship is a function? Let's write it in the form of ordered pairs. The answer is yes. This relationship is a function because each student has exactly one pair. Like set F equals Andy in 1, Budhi in 2, and Citra in 3. Alright, up to this point, do you understand the concept of set, relation, and function? I hope you do. Keep up your learning spirit and don't be afraid to try practice problems so you can understand better. See you in the next lesson. Bye bye.